The term power grid frequency, also known as grid frequency, describes the rate at which an electrical grid's alternating current AC power supply changes the direction. Grid frequency, which is typically represented in hertz, is a technical term that refers to the number of times the alternation cycle happens per second. Currently, 50 Hz is the common frequency utilized in the majority of the world's electricity systems. Accordingly, there are either 50 cycles per second, 2,400 cycles per minute, or 1 cycle every 20 milliseconds. Frequency refers to how often something occurs within a specific period. When you power up an appliance, like a kettle or laptop charger, it uses alternating current AC, which means the current alternates between positive and negative voltage. This back and forth movement, or oscillation, is termed electrical frequency. AC oscillates 50 times per second, resulting in a frequency of 50 Hz. Take an example of UK or India appliances and electrical equipment are designed for 50 Hz. If the frequency deviates from this, the appliances won't function correctly due to the narrow tolerance. Hence, maintaining a frequency close to 50 Hz is essential. Monitoring the frequency across the electricity network is crucial to ensure it stays near 50 or 60 Hz. Changes in supply and demand impact frequency, and excess demand drops the frequency, while an excess supply raises it. We are required to keep the frequency within 0.5 Hz of 50 Hz, but we aim for a tighter operational target of 0.2 Hz. The primary reason for accurate frequency control is to allow the flow of alternating current power from multiple generators through the network to be controlled. The trend in system frequency is a measure of mismatch between demand and generation, and so is a necessary parameter for load control in interconnected systems. Frequency of the system will vary as load and generation change. Increasing the mechanical input power to a synchronous generator will not greatly affect the system frequency, but will produce more electric power from that unit. During a severe overload caused by tripping or failure of generators or transmission lines, the power system frequency will decline, due to an imbalance of load versus generation. Loss of an interconnection, while exporting power relative to system total generation, will cause system frequency to rise. Automatic Generation Control (AGC) is used to maintain scheduled frequency and interchange power flows. Control systems in power plants detect changes in the network-wide frequency and adjust mechanical power input to generators back to their target frequency.